In this episode, we focus on three ideas that sound administrative but are actually central to trustworthy AI: proving who owns the data, proving where it came from, and proving how long it is kept. Beginners sometimes assume that once a model is trained, the training data fades into the background, but in real governance, the training dataset is part of the system's identity. If the dataset is questionable, the model's behavior becomes harder to defend, and if the dataset is mishandled, privacy and security risks can persist long after training is complete. Auditors and oversight teams do not accept claims like "we used approved data" or "we delete data when we are done" unless those claims can be supported with clear evidence. That evidence needs to be specific enough that another person can trace the story and verify it, even if the original team is gone. The goal today is to understand what it means to prove ownership, lineage, and retention in a way that stands up to scrutiny, and to learn how these proofs reduce harm and improve accountability. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. Data ownership, in this context, is not about who has the file or who wrote the code that processed it. Ownership is the accountable stewardship role that can answer why the data exists, what it is allowed to be used for, and what conditions apply. For AI training datasets, ownership matters because training is not a neutral activity. It turns data into learned patterns that influence future outputs. If ownership is unclear, anyone can claim the data is fine, and no one is responsible for enforcing constraints, responding to questions, or approving new uses. Beginners should notice that ownership becomes especially important when training datasets are created by combining sources, because the combined dataset may inherit obligations from each source. Proving ownership means you can point to a named role or team with authority, and you can show that this role accepted stewardship responsibilities. Evidence of ownership should show when ownership was assigned, what it covered, and how changes in ownership are handled over time. Without that evidence, governance becomes dependent on informal memory, which is a weak foundation for accountability. Proving ownership also requires proving that ownership is meaningful, not just a name on a page. That means showing the owner has decision rights over use and reuse, and that there is a process for approving training dataset creation and updates. Beginners can think of this like a library curator who not only knows what books exist, but also controls how rare books are handled and who can borrow them. If the curator has no control, the role is symbolic and does not reduce risk. In an AI setting, meaningful ownership includes the ability to approve data sources, reject unapproved sources, require minimization, and enforce retention. It also includes being the point of contact for questions and audits. Evidence of meaningful ownership might include approval records, documented decisions about permitted uses, and records of exceptions and conditions. When ownership is meaningful and provable, the organization can answer who was responsible for ensuring the training data was appropriate. That clarity is protective because it prevents blame spreading and supports systematic improvement. Lineage is the second major proof requirement, and it is about the dataset's ancestry and transformation history. Lineage answers questions like which original sources were used, how they were selected, how they were transformed, and how they were combined. Beginners should notice that lineage is crucial for both compliance and quality because the dataset's origin determines whether it was authorized, and the transformation history determines whether the dataset still represents what people believe it represents. If you cannot show lineage, you cannot confidently claim the dataset is legal to use, and you cannot reliably diagnose issues like bias, missing coverage, or unexpected patterns. Proving lineage does not require capturing every tiny detail, but it does require capturing the major steps that change meaning and risk. Those steps include filtering, labeling, deduplication, exclusion of sensitive fields, and any sampling decisions that affect representativeness. A strong lineage record allows a reviewer to reconstruct the dataset's creation without relying on informal explanations. That is the kind of traceability auditors look for because it shows the organization can control and reproduce critical decisions. Lineage proof becomes especially important when training datasets are created from operational systems. because operational data can include personal data, confidential details, and uneven representation. Beginners should understand that if you train on operational logs or customer records, you need to know exactly which records were included and why. Lineage should show whether the data was collected for the intended training purpose or reused under approved conditions. It should show the boundaries, such as which time periods were included and which categories were excluded. It should also show how the dataset was sanitized, such as removing identifiers or sensitive elements where required. When lineage is weak, teams can unintentionally include prohibited information, and they may not discover the mistake until much later. Another risk is that a dataset might include data from sources that have contractual restrictions, and without lineage, those restrictions may be unknowingly violated. Proving lineage therefore protects against both accidental misuse and false confidence. It also supports quality by allowing teams to see whether the dataset actually matches the use case it is supposed to support. Proving retention is the third major requirement, and it often receives less attention than ownership and lineage until an incident occurs. Retention means defining how long training datasets are kept, why that retention period is justified, and how deletion is verified. Beginners sometimes assume retention is just a storage cost question, but retention is a risk question because data that exists can be exposed, misused, or reused without proper approval. The longer sensitive training data persists, the longer the organization is exposed to privacy and security risks. Retention is also tied to purpose limitation because a dataset kept indefinitely can quietly be repurposed for new models without revisiting approvals. Proving retention means you can show that retention rules exist, that they are applied to training datasets and derived datasets, and that deletion happens when required. Auditors often look for evidence that deletion is executed rather than promised, because promises are easy and execution is what reduces risk. Retention proof also matters for trust because people and regulators increasingly expect organizations to minimize how long sensitive information is stored. To make these proofs auditable, it helps to understand what kind of evidence actually convinces an outside reviewer. Evidence needs to be consistent, time-stamped, and tied to the specific dataset and its versions. Ownership evidence might include a documented assignment, a dataset registration entry that names the owner, and approvals showing the owner authorized the dataset's creation and use for training. Lineage evidence might include source listings, transformation summaries, and records of key decisions like exclusions and filters, all linked to the dataset version used for training. Retention evidence might include a documented retention schedule for the dataset, records of retention review, and records showing deletion events occurred when expected. Beginners should notice that versioning is essential because datasets can change over time, and you must be able to prove which version was used for a specific model training run. If evidence does not link to a version, an auditor may question whether the evidence applies to the actual training dataset. Evidence must also be retrievable, meaning it can be found without heroic effort, because if it takes weeks to assemble, it suggests governance is not integrated into operations. A proof system is only as good as its ability to be used under pressure. Another important aspect is understanding how ownership, lineage, and retention fit together as a coherent story. Ownership tells you who is accountable for the dataset's use and governance. Lineage tells you what the dataset contains and how it came to exist in that form. Retention tells you how long that dataset remains a live risk and how the organization limits that risk over time. If you have ownership without lineage, you might know who is accountable, but not what they were accountable for. If you have lineage without ownership, you might know where data came from, but not who had the authority to approve its use. If you have retention without lineage, you might know when data is deleted, but not whether the data that was retained was appropriate in the first place. Beginners should see that strong governance requires all three because each one supports the others. Together, they create the ability to explain, defend, and improve AI systems based on facts. That coherence is what auditors mean when they look for traceability and control. A practical way to think about lineage proof is to focus on the decisions that change risk, because those are the decisions auditors care about most. For example, decisions about including or excluding personal data change privacy risk. Decisions about filtering certain categories change representativeness and bias risk. Decisions about merging datasets from different sources change obligations and permissions. Decisions about labeling and cleaning affect quality and downstream model behavior. Beginners should also understand that lineage includes the human decision points, not only technical transformations. If a team chose to include a certain subset because it was convenient, that decision should be recorded because it affects coverage and fairness. If a team chose to exclude a time period because it contained unusual events, that exclusion affects how the model handles similar situations in the future. Proving lineage means capturing these meaningful choices and linking them to evidence. When those decisions are documented, governance can be evaluated and improved rather than being based on hindsight guesswork. Retention proof also has some common pitfalls beginners should learn to avoid. One pitfall is defining retention for the source data but ignoring derived datasets, like training subsets, feature sets, or archive copies used for reproducibility. If the organization deletes source records but keeps training copies indefinitely, the data still exists in a different form, and the retention promise is incomplete. Another pitfall is keeping data for reproducibility without defining a safe method, because reproducibility can be important, but it must be balanced against minimizing risk. A governance approach might keep certain non-sensitive artifacts longer while deleting sensitive raw data, but that must be defined clearly and executed consistently. Another pitfall is allowing retention exceptions without recording them, which creates invisible risk that can accumulate. Beginners should notice that retention is not only about deleting. It is about having a controlled lifecycle where data is stored, accessed, reviewed, and eventually removed. Proof requires evidence of that lifecycle, including periodic reviews to confirm data is still needed. Without periodic review, retention schedules can become stale and data persists by inertia. Ownership proof also has pitfalls, especially in organizations where teams change quickly. A dataset might be created by one project team and then handed off to another, and if ownership transfer is not recorded, accountability becomes unclear. Another pitfall is naming an owner who does not have authority, which creates a symbolic role that cannot enforce governance. Beginners should also be aware of the difference between a data steward and a data custodian. The custodian may manage storage and access, while the steward makes decisions about purpose and permission. Ownership proof must clarify which responsibilities belong to which role so that questions are answered by the right person. Ownership also connects to approval and exception processes, because the owner should be part of decisions about new uses and deviations. If approvals happen without owner involvement, ownership is again symbolic. Proving ownership, therefore, includes proving participation in governance decisions, not just being listed in a catalog. That is what makes ownership credible. An overlooked part of proving these elements is ensuring that the organization can answer questions quickly and consistently. Auditors often sample, meaning they pick a dataset or a model and ask for evidence. If the organization can retrieve ownership, lineage, and retention evidence for the sampled item without confusion, it indicates governance is integrated. If the organization needs to scramble, ask multiple teams, or reconstruct records from memory, it indicates governance is weak. Beginners should understand that this is not just an audit performance issue. It reflects the organization's ability to respond during incidents. If an AI model produces harmful outputs, the organization may need to quickly identify what data it learned from and whether that data was appropriate. If a privacy concern arises, the organization may need to quickly identify whether certain data was included in training. If the organization can do that quickly, it can respond more effectively and reduce impact. Proof systems therefore support operational resilience, not just compliance. When you can prove ownership, lineage, and retention, you can also manage surprises more confidently. The big takeaway is that proving data ownership, lineage, and retention for AI training datasets is about building a verifiable story that links accountability, origin, and lifecycle in a consistent way. Ownership proof shows who had authority and responsibility for the dataset and its approved uses. Lineage proof shows where the data came from, how it was transformed, and what decisions shaped its contents and risk profile. Retention proof shows how long the dataset is kept, why that period is justified, and how deletion is executed and verified, including for derived copies. These proofs require evidence that is time-stamped, version-linked, retrievable, and coherent across the dataset's lifecycle. When these elements are in place, governance becomes defensible because the organization can show it did not just stumble into using data, but controlled it intentionally. That control reduces privacy and security exposure, improves quality, supports fairness analysis, and strengthens trust in the AI systems built on top of the data.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.